Here, just a quick recording of an DAA core node provisioning setup that we just finished. And before I'm gonna pass over to Jochen, maybe just 3 slides on the architecture, what is characteristic to that, to serve the demo later on with that information. So distributed access is an ongoing migration in service provider where you're giving up on the use of separate access infrastructure for every single service, being mobile or fiber to the home fixed, DOCSIS fixed, DSL fixed, migrating to a setup where you will separate the cores from the nodes and will insert a converged interconnect network, what is visualized here. And so will give you better return on your access infrastructure overall, because that is the goal. The cell sizes are shrinking. This portion is getting bigger and bigger. So the shared portion becomes, in this case, very, very big relatively to the overall access infrastructure that you need to deploy, with obviously better and positive impact on the OpEx associated with running these networks, and to some extent the CapEx also. Now, how do you provision a service node? What are we going to see in the demo that follows? We will assume that the service provider has, for its entire service area, mapped out that in what we call here on this graph logical nodes. These are service areas, as you see here with these smallest cells. In all of these will be installed a physical node. For the demo that follows, a remote PHY device, a DOCSIS remote PHY device. With all these logical nodes equal serving areas will be associated services. These services samples there is a broadcast video service that has typically a bigger serving group. This is broadcast. This is what we all get as standard national broadcast TV, for example, and that is the same for bigger regions, and that is reflected here by the biggest zone service group. Then narrowcast, this is covering, for example, VOD. These service groups are smaller, but the smallest service group always is the DOCSIS, the data service group, because this is where we have the highest consumption per subscriber per head. Then you also have cores. Service groups will be associated with service cores, so will your logical nodes and eventually your RPDs. And that is then what is shown in the next slide, is that every serving area, what is represented here in the slide, what I called earlier a logical node, has associated with it an node configuration template and a series of service templates: data, DOCSIS data, broadcast video template, narrowcast video template, and is also associated with a series of service cores. These can be living in the same data center in the same device, not necessarily so. And all these associations will be documented in a database that will be created and maintained by the video engineering and the data various service engineering groups. And at the time of installation, and that's exactly what Jochen will demonstrate, all that these associations will actually be used and carried over to a physical RPD device. We get a MAC that is associated with a device of a specific type. We can check for that type, and once so the provisioning process is actually that. So Jochen, I'll say steal the screen and show your demo.
Thank you, Dominic. So this being said, let's jump to DataMiner, and everything starts here with this table. This table is holding jobs to provision new RPD devices onto CCAP cores. Let's have a closer look at this table right here. There is only one new RPD provisioning job. Going from left to right, the first thing that we have here general template. So that means that DataMiner at some point will load configuration, as Dominic already mentioned, onto a CCAP core. We have a general configuration that has to be loaded. We have DOCSIS configuration for the data. We have here a video configuration, a video template. All of these three here are references to files, template files that can be found in these folders over here. Let's open the first one as an example, this video template. As you can see, this here is some kind of XML. The structure of this XML is Yang based, so it's based on Yang models. So it's really standardized. The goal is that we use here standardized Yang models from Cable Labs. What is the benefit of this? Well, that means that any device, no matter what vendor, we can load the same configuration and the same structure, no matter what vendor your CCAP core is. This XML of the templates will be loaded onto the CCAP core using netconf. So no CLI anymore. Everything is standardized and is sent via the netconf protocol. Going back to our table with our job, so we had our general DOCSIS and video templates defined for this particular provisioning job. The next field that you see here is the MAC address. This MAC address can come from an external database, from an asset management database, but evenly well, this could come from an external OSS app. For example, a technician in the field physically installs the RPD. Once it's installed, it scans, for example, the MAC address, and well, this can arrive here from the tool that he's using. So we know exactly, okay, this is the MAC address of the RPD that has to be announced or provisioned onto the CCAP core. The next thing is, of course, where it should be provisioned, on which core it should be provisioned. Then we have the port and slot number where it can be found. The model is also very important depending on what model. In this case, we have a Teleste Neo RPD device. Depending on this model, we might need to take different actions during provisioning. Then some SYN information for the network. This is here left blank for this demo. A device name, some service group information. The most important part is here the MAC address and here the templates. So then I only have to press this button here, the provisioning button. As soon as I click this, you will see some logs generated. And let's do this. It's reading the job, it's creating the RPD, it's now discovering the RPD onto the CCAP. All these steps that are logged over here, you can also find them there. So first thing that it did was reading, then creating, now it's doing a discovery. This takes about a minute before it moves to the next step. The next step will be, first, it will do the general configuration, then it will do the DOCSIS lineup, then it will check if it needs to create a video template, and all of that will be visible over here in just a few seconds.
It's a real demo.
What did you expect?
Good.
And now it's busy with the general configuration, the DOCSIS configuration.
Excellent.
And now it's creating the new video broadcast configuration. And now we have a state RPD provisioning finished. All the steps again, you can see them in here if it went
Excellent.
a little bit too fast. And now let's quickly with a CLI check if that RPD is really coming online. And you see indeed here, this is our RPD with this MAC address that is now appearing onto the CCAP, and you see it's already online for the moment.
Excellent, excellent. Thanks, Jochen. I just wanted to bring back one slide just before we close the demo, and this is this one, just to underline the fact that what Jochen just demonstrated is a workflow as we would associate with node initial deployment, where you will need to verify where your network, need to verify the network segment, the device. You need to create a provisioning file. You need to provision the core. The device is installed and it will be configured. And then hopefully you reach provisioning complete, as we've shown here during the demo. But as this is a fully configurable item, there is associated with every DA node, so RPD as we showed here in the demo, full lifetime orchestration requirements. And so we have also obviously support for scenarios where this device would fail, needs to be replaced, where you need to transfer configuration data from one MAC to another. And so that is one use case, but there's also use cases and so workflows associated with a service update if there was a change in the DOCSIS template as associated with that element, or with the video template, or with the device configuration in general. I'm talking levels, slope, just to give two examples. And there is also a workflow associated with the software updates. This is an element in the field. This is an element that sees its core software evolved, and so we will also need to support regular updates on that RPD. Just wanted to make that clear. Jochen, maybe before we close it up, maybe you can highlight or come back once more to the fact that we're using NetConf models and what is the benefit compared to doing that maybe traditional or using different schemes.
Yeah, usually CLI is used nowadays. CLI is not standardized. I mean, every device has a different command line interface. With NetConf YANG, NetConf is the protocol that is used to send data to a particular CCAP core. The YANG is really the model that is used, the structure of the messages, the structure of the data, the structure of the configuration that has to be loaded onto the CCAP. Using YANG models, and especially YANG models from Cable Labs, if you use that, no matter what the vendor is of your CCAP, the same configuration, the same DOCSIS templates, the same video broadcast, narrowcast templates can be loaded on, for example, a Cisco device or a CASA system device, just to call two examples. So that's the benefit. So you get rid of that unstructured CLI. You have a well-defined model for defining all your templates using a YANG model, basically.
Thanks for clarifying that, Jochen. Good. I think, Jochen, thanks for your help, and maybe we can close here the demo. And thanks and congrats for all the work from yourself, the team, and so great. Really excited with the results here.
All right. Thank you.
Thank you. Bye.